In this question, you're given a varying potential difference supply. That means it's a AC supply connected to a 50 ohms resistor and also connected to a CRO across the resistor. That means to say this is a AC supply and it's connected to the 50 ohms resistor, and this is connected to a CRO. That's why you're able to get this display on the screen and to provide this kind of waveform. Now, the next thing we need to know is the CRO setting. The Y gain is 10 volt per division. So if you look at it, so there are two divisions here. That means to say this AC supply is an alternating voltage of 20 volt, plus 20 and minus 20. So the V potential difference or the EMF is 20 volt. And for the time base is set at 0.25 millisecond per division. Now, one thing to take note is you have to identify what's the period. So can you see the one that I highlighted in red? This is one complete wave, and the duration here, that means two divisions, will be the period. So from here, you know that the period will be 0.25 times 2, 0.50 milliseconds. And take note, it's very important to change it to SI unit. 1, 2, 3, jump to the left 3 times, divide by 1000, 0050 seconds. Alright, next, we are required to find the energy dissipated in the resistor for one period, and we have already found the period from here. So now, because we are finding energy, many of you will think of the formulas that I ask you to memorize. You can think of E equals to PT or E equals to VQ. Now, both are possible to find the energy, but of course, most of you, I would think that you will think of using E equals to PT. But the thing is, I do not know the power, so you have to do additional steps. Now, the easiest and the fastest is if you know that power equals to V squared over R. This is actually much faster because you're given the R and you know the V of the varying potential difference. So that will be 20 squared divided by 50, and the power straight away you can get as 8.0 watts. Alright, then from here you can sub into the equation E equals to PT. The power is 8.0 and the time taken we have determined just now, 0.00050, and that works out to be 0.0040 joules. And since all the answers are given in millijoules, you have to convert joules to millijoules, basically divide by 1000, so it will be 4.0 millijoules. So the answer is C. Of course, if you did not think of using power equals to V squared over R, you can also use power equals to IV. And since you do not have the I can find the I using V over R, which is your 20 volt divided by 50. Then you find the current, okay, which is 0.4 ampere. Then you sub inside here, then you sub inside here. Okay, that will be slightly longer. It doesn't matter. Now, of course, some of you may, what if you think along this using this formula from the start? The answer is you can still do that also. So what we need to do, we already know that the V, the potential difference, is 20 volt. What I need to find is my Q equals to IT. As mentioned just now, the current is 0.4 ampere. So 0.4 times the time, which is 0.0005 seconds, you will get that the amount of charge will be 0.00020 coulomb. And then with this charge you sub inside here, you will get the same answer, which is 4 millijoules. So whichever formula you use, whichever method you use, you will get the same answer. Alright, just be mindful of the units. Alright, thank you.